Okay, this is session 2, Per Capita, Proportions, Statistics, and Weighted Averages. A lot to go through. My name is still Ryan Pennell. This is August 25th, 2021. So what we'll do with this module is homework section 4, homework section 5, homework section 6, discussion 2, and quiz 2. I will say that homework section 6 is split up into 2 parts, just like the textbook, but that does not mean that it's twice as much homework. There's only 5 questions per those parts, so at least for homework section 6, it's the same amount of homework. Now, we have 3 homework sections this week instead of the 2 that we had last week, but hopefully we, kind of know how the homework goes, how the class is working, and so we're a little bit more comfortable with the system. You do not need to schedule your exams. I've had some comments, I've had some emails mentioning this. I think it was the confusion from the syllabus, which is on my fault there. But you do not need to schedule your exams. We are going to do the proctoring through software. So it is not necessary in any way to schedule an exam because it's going to be done through software. So no particular person is going to watch you. It's going to be the software that monitors you. So please don't worry about that. And we'll talk more about the exam next time. All right, let's get into section 4, per capita and proportions. Last week, we discussed proportions. Of course, we did many problems in the homework and in the quiz. Section 4 involves these what-if problems. And that's another way of saying we're going to do some word problems with proportions. Problems in these sections will solve expected value. So it's like, I guess, what if value? What if this was the case? What would the value be? So let's just get right into an example and it'll clear everything up. So the first example, we see this table with cities in Indiana: Indy, Muncie, Carmel, Lawrence. Okay, the sales figures for each city and the number of customers. Well, this is just a made up scenario of, I don't know, let's say it's some business. But let's find the expected number of sales for Indy if it was proportional to Muncie with respect to its customers. Okay, so with respect to its customers, we're looking for the sales. That's like saying let's say, what if we didn't know the sales figures for Indy? What would it be if it was proportional to Muncie? So we need to set up a proportion with the customers and then all of the knowledge we have with Muncie. So on the right-hand side, you see the values for Muncie, the sales figure over the customers. On the left-hand side, you see an unknown number, x over 60. Okay, that's 60 that we have for the customers. So let's solve for x. We can do that by multiplying 60 on both sides. And if we multiply 4,012 times 60 equals, divided by 32, we're going to find $7,522.50. So that would be the sales for Indy if Indy was proportional to Muncie. Another way of saying Muncie is killing it. Muncie's doing awesome. They're doing better than if everything was proportional, they're actually doing better, right? Doing better than Indy is doing. So proportionally, they're doing better. Awesome. Let's look at another example. Find the expected value sales for Carmel if it was proportional to Indy with respect to its customers. So this time, we're saying, okay, use the information that's given for Indy and see what the sales figures would be for Carmel. So it's very similar to the last problem, except it's different cities. So x over 21, 21 being 21 customers for Carmel. On the right-hand side, we have Indianapolis. We have our sales figures divided by the customers. If we multiply both sides by 21, then we can find the sales figures. If they were proportional to Indy, Carmel's sales would be $2,384.20. Now, what can we infer by that information? Well, I can say that since Carmel's actual sales figures is $5,100, and if it was proportional to Indy, it'd only be $2,300, that means that you can either say that Indy's not doing as well as it should, or Caramel's doing better than it should. But judging by the last problem, I think I can say that maybe this Indy location is a little lackluster. Okay, but that means Caramel's doing great. So good job, Caramel. All right. Another example. What is the expected number of sales for Lawrence if it was proportional to Muncie with respect to customers? So this is a very similar question. We're looking for the expected number for Lawrence given the information from Muncie. So I'll do right hand side with Muncie, left hand side with Lawrence, and the unknown sales over 50 customers for Lawrence. If I multiply both sides by 50, I will find the expected sales figure, and that is $6,268.75. Now, what was the actual value? What was the actual sales for Lawrence? It was roughly $4,000. So that means, I suppose, that they are doing a little bit lower in sales than they would if they were proportional to Muncie, right? But maybe Muncie's just one of those locations that is, I don't know, just doing really well. And that happens sometimes in business. All right. Next, I want to talk about inflation. Inflation is extremely hard and an abstract concept to talk about, but I'm going to do it anyway. So, when we talk about inflation, we have to talk about the Consumer Price Index. What is the Consumer Price Index? The CPI is a monthly number that reflects the changes in the prices for goods and services. You can do monthly for sure in real life. This is just math class. This isn't real life. We're not really analysts. So for our purposes, we're just going to use yearly. We're just going to look at it yearly, not monthly. But you can get down to the month if you need to. It can be used to make predictions for the future or the past prices since it describes the prices were at that time. We will refer to section 4 of our textbook for CPI values during the homework. In my textbook, it was page 41. It's going to be roughly that same page for your textbook. You might add or subtract a page there. It might be 40, 42. It's going to be somewhere around there. You're going to see this table. I went ahead and put it in my slides so we can all have the same table that we're looking at. This is the table I'm going to refer to within this lecture. And this is the table of the CPI values. On the left-hand side, you see the year, which is only going from 1977 to 2017. And then the annual, well, what is this annual? Annual means year, of course, but what does that number mean? This means roughly, it's kind of like a price, but it's not a price, okay? So the CPI doesn't have any units, but it's a bit like the money. And as inflation works, the value of the dollar goes down, and so the cost of particular items goes up, right? So the cost of food has gone up, the cost of movie tickets has gone up, the cost of college has gone up, right? And that all being said, the value of the dollar in turn goes down because that is a proportional, they're inverse proportional to one another. So again, let's look at some examples and clear this up. So first example, I want to look at hamburger costs. If a hamburger cost 38 cents in 1979, what would be the equivalent price in 2017 if it followed inflation perfectly? So the CPI values for 2017 was 245.12 and 72.6 for 1979. Let's set up a proportion and try to solve the price of that hamburger if it followed perfectly. So on the left-hand side, I put the prices. So X is going to stand for the price in 2017. On the bottom there, it's 38 cents. That is for 1979. On the right-hand side, you see the CPI values on top. Again, I have 2017. On bottom, I have 1979. Now I can just multiply both sides by 38 cents, and I can solve for that price of that hamburger. And I found $1.28. So that means that if hamburgers followed inflation perfectly, then the hamburger in uh, 2017 would be roughly $1.28. Is that an accurate description of the cost of hamburgers in 2017? I would say it depends. It depends on what is your definition of a hamburger, right? If you go to McDonald's dollar menu, I believe they did have a hamburger or a cheeseburger for $1. And I guess, in Bloomington that would have been what, a dollar 08, roughly a dollar 08. So yeah, I mean, I would say it would have been close. It would have been close if you're looking at the dollar menu. If you're looking at, say, a quarter pounder, it's going to be more, right? But a quarter pounder, of course, is going to be much more food than, say, a hamburger in 1979, right? So food portions have gone up, prices have gone up, so that makes everything more complicated. But I would say on the dollar menu, if that was roughly equivalent to the same size, I would say the hamburgers have roughly followed suit, give or take. Let's look at another example. So what is the price of tuition in the year 2010 if the price was $1,865 in 1995, and then with the given CPI values of 218.056 for 2010 and 152.4 for the year 1995. So let's set this proportion up and see if we can't solve if tuition for college followed exactly with inflation. So on the left-hand side, you can see I have my prices. I have my unknown price for 2010 as X. On the bottom, you can see I have the price for tuition in 1995. On the right-hand side is the CPI values with 2010 on top and 1995 on bottom. I can multiply both sides by 1,865 to find this tuition. I found $2,668.47 was the price of tuition in 2010 if it followed perfectly with inflation. Would you agree? Would you disagree? Do you think that college cost $2,000, between $2,000 and $3,000 in 2010? Well, I can tell you it didn't. Of course, college has inflated in cost much, much, much more rapidly than the inflation of the dollar. There's a lot of reasons for that, but one of the reasons is the demand for it is much, or at least in 2010, the demand was extremely high versus the supply. So in 2010, it was often that you would sit in a classroom, there would be a teacher in front of you, that kind of thing. And in that kind of setting, there's only so many seats, there's only so many physical locations. Well, in 2021, things have certainly changed. Things are going online. Limited seats are not so much. Class sizes can go up. Availability can go up. And yeah, it's not completely unexpected that you will have much larger class sizes, but the knowledge will be given to you in a different way. Long-winded way of saying that the supply is growing, the demand is about the same, and so I believe that the tuition cost for college we will see in the next 10 years actually go down, and for these reasons. Okay, tangent put aside. Find the equivalent price of a calculator in 1986 if you paid $15.89 in the year 2012. We're given the CPI values of 229.594 for the year 2012 and 109.6 for the year 1986. We can set up our proportions just like before. On the left-hand side, I have the unknown value of the 1986 calculator. On the bottom, I have the 2012 price. And then on the right-hand side, on the top, is the CPI value for 1986. On the bottom right-hand side, we have it for 2012. Now, We just need to solve for x, and we should be able to find our value. I'll multiply both sides by $15.89. When I do so, I find $7.59. Now, do I think that the price of calculators have followed inflation? I do not. Technology, for the most part, kind of works on its own system. It doesn't really work with inflation in that way. So the price of a calculator in 1986 would be much, much more. I would say probably on the order of maybe, order of 10 perhaps. I'm just guessing, but I'm thinking that a calculator in 1986 for the same with the same functions and everything in 2012, I would gauge that it would be a couple $100 versus almost $8. That's not going to happen. So technology is one of those things where it kind of goes with its own trajectory. It doesn't follow the U.S. dollar because technology is kind of a newer thing, and it kind of works on its own curve. So it's kind of funny to think about, but yeah. So this calculator in reality would be worth much more in 1986. Section 5, working with percentages. So percentage means 100 per 100, right? So 20% is 0.2 or 20 over 100. Use your number sense when working with percentage questions. Ask yourself whether or not an answer seems reasonable. Well, you should always do that, of course, but it is important to have consistent algorithms. Use a step-by-step procedure to set up and solve these equations to be confident about your answers. Let's look at some easy questions real quick so we can get our footing here. If we look at 20%, we want to turn this into a decimal. You could divide 20 by 100 to find the decimal equivalent. That's going to be 0.2. You could also think that you move the decimal place 2 places to the left, right? That's another way of thinking of how we got that decimal value. For something like 33.78%, you could divide by 100, or you could move the decimal place 2 places to the left. It's totally equivalent, and you'll find 0.3378. Same thing with 300%. If we want to turn that into a decimal value, what can I do? I can divide that by 100. I find the number 3, or you can just say I move the decimal place 2 places to the left. What about 0.22%? Well, you got to move it 2 places to the left, or you said, well, I divide it by 100. It's going to be 0.0022. Okay. Let's go the other way. Let's go from decimals to percentage. In this way, we are going to multiply by 100. So 0.97 would be 97%. 0.6788 would be 67.88%. 0.00347 would be 0.347. Notice that it's still a decimal, even if I move the decimal place 2 places or multiply it by 100. It's still a decimal, and that can happen sometimes. A little confusing, so watch for that, but yeah, so that's still true. And then the decimal of 5, well, that's going to be just like our 300%. That's going to be 500%. Okay, so I hope that helps. Next thing I want to look at is equation method. So we are going to look at some word problems for percent problems. And doing this, generally students want to use an equation method. And that's what I want to talk about now. So we can solve percent problems by proportion or equations. If we choose to use the equation method, we will use percent times base equals amount, or P times B equals A. It may be helpful to use the phrase, the percent always acts on the base. Okay? We will always choose to use a decimal version in our equations rather than the percentage. That being said, for 20%, we're going to use in our equation 0.2 instead of 20. Okay? Let's look at that equation one more time. So if we're going from proportions to this equation. We can do this by looking at if you see that proportion is over 100, well, 100% is simply 1, so we can form this equation. Now let's look at some examples and see how this works. What is 0.0056% of 24,000? What number is that? So 0.0056% of 24,000 is what number? So let's set up our equation. Percent times base equals amount. So the percent is obviously that 0.0056%, but I have to move the decimal place because they gave me a percentage. So I have to move the decimal place 2 places to the left. I multiply it by 24,000, and that is going to be the amount. What is that amount? It's 1.344. So 1.344 is 0.0056% of 24,000. Kind of a hard example, but you'll see ones very similar in the homework, so I wanted to do something like that. All right, so 1.344 as the answer. Okay. So another example, 200% of 17 is what number? Let's set up our equation. Percentage times base equals amount. Okay, well, the percentage is 200, so that's 2. The base is 17, so the amount will be 2 times 17. And what's that? That's 20 plus 14, that's 34. So it's 34. Okay, let's look at another example. 18 is what percentage of 90? Now we're looking for the percentage. We're not given the percentage. We are looking for the percentage. Okay, so here's our equation. Percentage times base equals amount. Well, what is the amount? What is the base? So I like to look at the is and of. It's kind of how I do these problems. So of 90 tells me the base. Is 18 is the amount. So the equation will go x times 90 equals 18. 18 is what percentage of 90? So that means I have to divide both sides by 90 to acquire x. And what would that value be? It would be 0.2. Well, what is that percentage? That's 20%. Okay, so that's how you can find what is the base, what is the amount, and how to solve for percentage. I hope that helps. Word problems. Let's do it. If you paid $169.52 in income tax on gross monthly income of $1,304, what is your income tax rate? First, identify the amount, base, and percentage. Here, the percentage is unknown. The base is 1304, and the amount is 169.52. Okay, so let's look at our equation. Percentage times base equals A. So what is the percentage? What is the base? What is the amount? Well, we're looking for the percentage, so that's what's unknown. What is the base? This is where my is of kind of comes in, and it says gross monthly income of 1304. So that's letting me know that that is the base. Okay, so the 169.52, that is the amount. So I set up my equation, percentage times base equals amount. I can divide both sides by the base, which I've done so here. I find 0.13, that's 13%. So we paid 13% in income tax. Let's look at another one. This one's about text messages. Out of 600,000 text messages a month, only 0.85% go to your uncle. How many texts are sent to your uncle? All right, well, we're given the percentage. Are we given the amount or the base? What do you think? Amount or base? It says of 600,000. So I would say that this is the base. So I'm going to set up my equation with percentage times base will equal the amount. Don't forget, I have to turn that percentage into a decimal. I've done so there. And that goes to 5,100 texts a month, which is still, I mean, that is a lot of text messages to your month. But to your uncle, but 600,000 texts is a lot. So, everything's relative, I suppose. Okay, and section 6 is about statistics and weighted averages. It discusses basic statistics, including how we focus on taking averages. We will find the average in 3 ways: the mean, median, and mode. The mean is the sum of the set of values divided by the number of values. The median is the middle number, and the mode is the number that occurs most often in the set. I've rewritten these in more simpler terms. The mean is the average, okay? The mean is the average. Chances are you already know what average means, and that is exactly what I mean by this one. The median is just the middle number, okay? And the mode is the number that occurs the most. So let's take a look at an example. So find the mean, median, and mode from the data set 2, 3, 4, 5, 7, 9, 10, 10. All right, well, what is the mean? The mean is the average. How do you find it? You add all of the values up, and then you divide by how many values you added. So 2, 3, 4, 5, 7, 9, 10, 10. Add those up, divide by the 8 numbers we just added. That would be 50 divided by 8. So the average is 6.25. That's the average in there, okay? The median is the middle number. Well, what is the middle number? You have 2 on one side, 10 on the other. If you go down the middle, you'll find there is no middle number because there's an even amount of numbers, and that's kind of confusing. So the middle number is somewhere between 5 and 7. Well, how can I calculate that? 5 plus 7 divided by 2 is 6. So 12 divided by 2 is 6. So that is the middle number, okay? Even though it's not represented in the data set, that's okay. The median is 6. The mode is the most occurring number. Well, in this data set, what number occurs the most? 10. 10 occurs twice. So the mode would be 10 for this example. Let's look at another example. If I have a different data set, 79, 32, 84, 57, 65, 51, 84, 98, 32, what is the mean? That is to say, what is the average? Well, add all of the numbers up, divide by how many numbers you've added up. So we add them all up. There's 9 numbers, and we find that that the average is 64.67. So that is the average number. Now the median is the middle. Since we have an odd amount of numbers here, we actually will have, we really will have a middle here, and that middle will be 65. Now, we need to have the numbers in order for that to work. Otherwise, it's not going to work at all. So you have to put them in order, and that's what I did here at the bottom, where I put everything in order, and then you can just take away one in the back, take away one in the front. You go one for one, and you'll find you'll be left with 65 in the middle. Okay. Now the mode is the number that occurs most often. What number occurs most often? Well, we have a duplicate of 32. We have a duplicate of 84. There technically isn't a mode because no number occurs the most. So we kind of had a tie. That's kind of funny, right? We have numbers that occur more than once, but no number that occurs the most. So there is no mode here. Let's look at another example. 12, 95, 65, 71, 13, 65, 66, 90, 80, 55, 60. What is the mean? Well, that's the average. Add all the numbers up and divide by how many numbers we have. We have 11 numbers, so you can see what the mean is roughly 61.09 repeating. What is the median? It's 65 again, coincidentally. We have to write them in order, though. That is the best way to do that. And then what is the mode? That's the number that occurs the most. In this, 65 occurs the most out of all the numbers. So this one did have a mode. Okay. Descriptive statistics. This one is a little bit confusing. I hope to make it super easy. So in some cases, Data may be more prevalent in one area than the other. When we put into a chart, we can describe the graph in 3 special ways: right skewed, left skewed, symmetrical. A graph can also be none of those, of course. See page 60 in the textbook for further information, but let's look. Right skewed means that the mean is larger than the median. That means that the average is larger than the middle. That will be referred to as right skewed. Left skewed means that the mean is less than the median, and symmetrical is when they're equal. And I have some pictures here I stole from dummies.com, and it's kind of like the opposite of what you would think. So in that top left, that is actually right skewed. It looks like, oh, well, that'd be left skewed, right? There's more of it on the left, but that's not quite true. It's actually skewed to the right. Now, on the top right example there, that is going to be left skewed. That is left skewed. Diagram B there is left skewed. It looks like, oh, well, that'd be right skewed. All the data is on the right, but no. That means that the mean is less than the median. And then symmetrical, that is figure C there. That means that they're equal, and you can see that it is very symmetrical. All right, next thing is how can we use Excel with descriptive statistics? So Excel can be used quickly to calculate descriptive statistics. Excel has many pre-programmed functions built in, such as the mean, median, and mode. See page 60 in the textbook. All right, but I'm going to focus on a few. The mean, we can type in equal sign, average, open parenthesis, colon, close parenthesis, and it'll actually calculate it for us, which is awesome. The mean, almost the same thing. If you hit equal sign, start typing median, and then tell it which data you want it to use, you can have it calculate the median, the middle number, and it will also calculate the mode for you by just hitting equal sign, mode, and then whatever you would like it to do. So I've done that here with the data 12, 32, and 34. The mean, median, and mode, you can see that the average here, this would be cell A1, B1, C1. We have 3 cells there. And the average, the median, and the mode. The average here would be 26. The median would be 32. And the mode does not exist because the mode, there's no most occurring number there. So there's no mode. So it's blank. Okay. So part 2 discusses basic statistics, including how we can focus on averages. For part 2, we're going to talk about GPA, course grade, class averages. So GPA is a grade point average. Course grades, I mean by weighted course grades, like we have for this course. Class averages are the average points for the entire class. 2 methods: method of counting, method of percentages. So for method of counting, it's the value times the count plus the value times the count divided by the sum of the counts. That's exactly what we did before. Okay, that's what we were doing before. Now the percentage is the weight, and that's how our grades are calculated in this class. For instance, homework is worth a certain percentage, exams are worth a certain percentage, discussion sections are worth a certain percentage, and that's how your grade in this class is set up. So let's look at an example of that right now. So let's say tests are worth 60%, homework's worth 20%, and quizzes are worth 20%. So that sums to 100%, right? Let's say this student got an average of an 85%, homework 100%, quizzes 85%. What would their course grade be? So that would be 60% times 85 for the exams, 20% times 100 for the homework, and 20% times 85 for their quizzes. Don't forget to turn those into decimals. What do we get? We get 88. So their grade would be an 88%. Okay, 88%. So that's really good, right? That's a B. It's a high B. It's like a B plus. All right, calculate the GPA for a student with the following grades. Ivy Tech uses a general grading scale for all of these problems, such as A equals the value of 4, B is a 3, C is a 2, D is a 1, F is a 0. So, let's look at the report card. So, for history class, there was a 3 credit hour history class. They got a B. Physics class was a 5 credit hour. Must have had a lab included there. They got a grade of D. For another lab class, that was a 2 credit hour. They got an A. IV prep class was 1 credit hour. They got an A. And finite class was a 3 credit hour class, and they got a C. Okay, so what would the points be worth? Well, notice that B is worth 3 points. So the points are going to be 3 times 3. For physics, they only got a D, so that's a 1, so 5 times 1. For lab, they got an A, it was worth 2 credit hours, so that's 2 times 4. IV prep is 1 credit hour, they got an A, so that's 1 times 4. Finite class, they got a C, 3 credit hours, so 3 times 2. Let's find that GPA. If we add all of the points divided by adding all of the credits, we will find this GPA. So 32 over 14 is roughly 2.29 for their GPA, and that's roughly that's a C. That's like a C average grade, right? So they roughly got a C for, I guess, this semester. Okay. Let's look at some more examples. So in this one, this is like a grade book for a particular student. So what would be the average of their midterm, average of the final, average of the homework, average of the quizzes, average for the group work? Okay, well, we don't really need to average the midterm. There's only one score. Average for the final, there's only one score. For the homework, we will need to average. For the quizzes, we will need to average. For the group work, we will need to average. Let's do so now. So with the final grade, we just supplement the weights, 25% for the midterm times the average score, 30% for the final times the score, 15% for the homework times the average score, then quizzes times the weight, group times the weight, and we find 80.84 for the class grade. So I would say 80.84 in the Ivy Tech scheme, that's going to be a letter grade of a B. Okay, all right. So for our next example, find the average price in a day of a store that sells 28 regular comic books at $16, 9 rare comic books at $30, and 2 mint comic books at $50. I believe that mint is like a like pristine copy of an older issue. I don't know that much about comic books, but I believe that that is what it is. So that they're worth more, essentially. They're worth more. Okay, so to do that, we need to times it by the amount. So we sold 28 regular comic books at $16, so you can see I multiplied that. We add in the 9 rare comic books we sold at $30, plus the 2 that we sold at $50. That would be the numerator, the top. Then we divide by how many comic books we sold, which would be 28 plus 9 plus 2. And so that is going to be an average price of $20.97. Okay. So that would be the count method that we talked about earlier, the count method. In the next example, what is the average salary of a company if 18% of its employees make $36,000, 68% make $44,000, and 14 make $64,000? Well, this is going to be the weighted situation since we have a percentage. So 18% times the 36, 68% is the 44, and the 14 will be times the 64. Now remember, we have to turn these into decimals for that to work, but once we do that, we find the average salary is $39,528. So there we used the weighted system. So in this example, what is the average grade for this semester for the class size. So we have a class size and we have a class average. So for 18 students, it was 85.2, roughly a B. For a class size of 21, it was 90. For a class size of 17, it was 82. And for a class size of 12, it was 67. So what is this class average? Well, what I would do is I would use the counting method. So 18 times 85.2 plus 21 times 90.1 plus 17 times 82 plus 12 times 67.8. And then we divide by how many people. How many people are the class sizes? So 18 plus 21 plus 17 plus 12. So that is, on the numerator side, 5,633.3 divided by the 68 students. So the average class grade would be an 82.8. Okay. So it would be. It would roughly be a B. All right. So what's due? Homework sections 4, 5, and 6, the discussion section 2, and the quiz 2. Next time, we're going to talk about the exam, we're going to talk about the project, and we're going to talk about section 7, interpreting change. So only one new section next time. This time we went over 3, but we have to introduce the exam and the project. Big things coming up for next time. So that is the end. As always, if you have any questions, please reach out, and I will see you next time.